Now let us discuss this problem. So this says an alkene A. So I have an alkene A, and the formula is C16H16. So a big alkene. On ozonolysis, so if I do ozonolysis, give only one product B. So this means a symmetrical alkene. So V is only one product. You're getting? So question says this gives only one product. This must says that my alkene has to be symmetrical. So this is a symmetrical alkene. It has to be symmetrical. Are you getting? Now next says, and the B molecular formula B is also given, C at H at O. So you see this has divided into two parts. So initially you have 16 carbon. Now we are getting 2 molecule of 8 carbon. So this has been divided into two parts. That is, this also suggests symmetry. The compound B on reduction with reaction with NaOH I2. So if B is treated with NaOH plus I2. And now if you remember, this is the iodoform test. NaOH plus I2. This is the iodoform reaction, and this is given by methyl ketone. Yields sodium benzoate. So the product is sodium benzoate. So benzoic it is this. Sodium benzoate will be this. So you have this and COO minus plus. So this is a salt of benzoic acid. So this is sodium benzoate. So this is one product. Reacting with NaOH2 gives sodium benzoate. Compound B reacts with, so compound B further. So compound B if treated with NH2OH minus, yielding a hydrocarbon. So this is a NH2. So let me write this reacts with NH2OH minus, and this reaction is nothing but Wolff-Kishner reduction reaction. It gives compound C, and C has a molecular formula of C8H10, and this is a hydrocarbon. C is a hydrocarbon that is given to you. Are you getting? Now the question again says write down the structure of BC based on the information. 2 isomeric structure of A can be proposed. Write down the structure and also write down the isomers. So let us write down the structure of ABC. Now you see, let us go for this reaction. This reaction, if C at H at O treated with NaOH2, this gives this compound. Now how many carbon we have? We have 6 carbon plus 1 carbon, 7 carbon. Here how many carbon we have? 8 carbon. So 1 carbon has been lost during this reaction. And this reaction is nothing but iodoform reaction. Iodoform reaction is given by methyl ketone group. So you must have a CO is here. So this means in this compound there must be a CH3 group that should be attached here. And then only, so if you have a CH3 group attached at this position, and then we will have only methyl ketone group. So now I know the structure of B. So obvious. So a structure of B will be, so easy problem, you see. So this is a methyl ketone group, and now if you treat this compound, it will give the iodoform test because we have the methyl ketone group. Now the two molecule, if you take the two molecule of the same compound, so I can also write PHCO CH3. This is one molecule, and I have to take the another molecule and add. So let me write something different, PHCOCH3. And if I take another molecule, CH3, PH, and then if I add, I will get the final alkene A. Are you getting? So this is my B and this is my A, PHCCH3, CCH3, and then you have pH. So this is the initial compound you will have. So this is A. Now question also says A exists in two isomeric forms. So that is obvious. This can exist in cis and trans. So A will have two isomer, cis as well as trans isomer. Are you getting? Now the question says write down the structure of C. So C is nothing but NH2 NH2OH minus. CO will be converted into CH2 group. You can see here itself. So you have 8 carbon, 8 hydrogen and 1 oxygen. So you have 10 hydrogen now. So 2 hydrogen. So you can clearly see 1 oxygen is replaced by 2 hydrogen. This means CO group has been converted to CH2 group. So what is happening? So you have B is this PHCO and then B is COCH3. And now if you do Wolff-Kishner reduction, that is NH2 NH2OH minus. Are you getting? So in that case you will have PHCH2. CO will be converted into CH2 CH3. So this is my C. And now this is basically Wolff-Kishner reduction reaction you have here. Now question also says write the structure. So we have to write down the structure of isomers. So these are 2 isomers. And identify the isomer which on catalytic hydrogenation gives racemic mixture. So now we have basically here 2 cis and trans. So let me write here. So for A we have 2 structure. So A can be either cis or it can be trans. Are you getting? So you can have either this PHCCH3 double bond CPH CH3, that is cis, or you can have another option, that is trans, C double bond CPH PH. Now this side you will have CH3 and then PH and then CH3. So this is trans. Now the question says if I do hydrogenation of this and if I do hydrogenation of this, which will give the racemic mixture? Now cis addition of hydrogen is cis, cis addition is cis, so product will be meso. Are you getting? Now this is trans and hydrogen addition is syn, so you will get racemic mixture. Are you getting? So in this case you will get racemic mixture, but in this case you will get meso compound. So the product will be something like this. So if you do hydrogenation, CPH CH3H PHCH3H. If you wish, you can draw the feature projection formula also. So this is racemic mixture. So we can draw the feature projection formula. So this carbon contains hydrogen, this also contains hydrogen. You have pH, you have CH3, you have CH3 here, you have pH. So this is 1. And you can have mirror image of this also. So if you draw the mirror image, you will have hydrogen, hydrogen. And here you will have CH3, pH, CH3. Are you getting? So if you take the cis isomer, you will get meso, but if you take the trans isomer, you will get the racemic mixture. And question says which will give the racemic mixture. So trans will give the racemic mixture. We'll discuss the next problem. These are the easy problem.